Okay, so in this video, we will be discussing the presentations that were presented to you in Module 3, or not Module 3, but week number 3. So, um, if we go to mrhelp.net, you can see here Module 2, Presentation 1, Synchronous Session 2 last week, and Asynchronous Session 3 last week also. So you have here a web page on plate boundaries and a presentation on types of plate boundaries. So we get to discuss what they are. So if we click on this one, this will appear. So notice the instruction here says visit this web page, study its content, after which answer the accompanying quiz. So the accompanying quiz is this one. So this is the website or web page. So here it's interesting that the page is referring to 15 tectonic plates. Okay, whereas in our discussion we referred to 7 major tectonic plates, 7 minor tectonic plates, and we also mentioned Juan de Fuca, which is something that some books mention, some other books also do not mention. So it's just so happened that in your grade 10 book, Juan de Fuca is not mentioned. So you have to kind of think about why this page mentions 15 major tectonic plates. Okay, so again, as I have told you, science is when you learn science, you have to approach it with an open mind. You don't want to be bookish about it. You don't want to say, okay, there should be 7 major tectonic plates, 7 minor tectonic plates, and that should be it. There's no, I mean, if another source would tell me that there are 15 tectonic plates, I would not believe it. Okay, so think about it logically. Why do you think this one refers to 15 plates rather than 7 and 7? 7 major and 7 minors. Okay, so here, uh, I like this site because again, it discusses that between tectonic plates, say for example, South America and Africa, yeah, they share a boundary between them, right? And in that boundary, obviously, the two plates at the other side of the boundary would have to have some interactions, and the interactions are such. So the two plates could move towards each other. So again, this is a GIF, I believe, and so it replays. So do not be confused. Um, are they moving apart or are they moving towards each other? Now, look at the arrows. So the arrows means they are supposed to move towards each other. It's just that it's a GIF, so it has to loop back to the beginning. So temporary, it looks like they are moving apart. But what is being emphasized there are the arrows. So the two plates are moving and actually colliding with each other. Now, a divergent boundary means you have a boundary and the plates on either side of the boundary are trying to move apart, move away from each other. Okay? And then a transform boundary occurs when they are not moving towards where, nor are they moving away from each other, but they kind of move just sliding and rubbing each other's edges. That's what we call a transform boundary. Again, if you dig into this deeper, convergent, the word convergent is from convergence. Convergence means to meet. Divergence, that means to move away into different paths. And so that's why we call this convergent boundary, divergent boundary, and transform boundary. Okay. Now I like this page because here, just with a click of a button, you can actually see where are the boundaries that have convergent um, interaction between them, divergent or transform. So if I click here, all of those red edges there are the divergent boundaries. I mean convergent boundaries. So you can, for example, see the Indian plate shares a border with Eurasia, and that border is a convergent boundary. Okay, and then divergent boundary are those. So there are a lot of them. So we can for example, see the generally, again, generally, the South African plate, I mean, the South American plate and the African plate are moving away from each other. Okay? Now, I can uncheck that and I can go to transform. And then if you look at transform boundaries, it's curious because where there are divergent boundaries, you can actually find transform boundaries. Okay? So think about that. Think about that because it's not it's a subtle thing, but if you try to simulate edges, it actually makes sense. Okay? It actually makes sense. So so try to imagine this one and that one, and try to imagine what could be the movement of the African plate and the South American plate for these parts to be diverging, yet these parts to be um, transformed, right? So think about that. That's a very good exercise for your brain. So here are your convergent boundaries, your divergent boundaries, and transform boundaries. Notice convergent boundaries seem to be convergent and no mix. There's no mix of transform boundaries. But where you can find divergent boundaries, you tend to find transform boundaries also. Okay. Now a lot of students got confused when I put in the instruction. Um, Answer the accompanying quiz. They thought the quiz I was referring to here is this one. No, you can look at this activity challenge and it would be fun, but that's not the intention. I mean, you can learn a lot of things by doing that, but that's not the intention of the instruction. What I meant as the quiz was um, the questions after that. And again, as I have already mentioned to you, some people did not get to see this because they did not check this box. So you have to check it before it would appear as accessible. Now, in this case, it doesn't appear accessible now because it's already um, after November 3. That was the deadline. So, but don't worry, for those people who were not able to kind of answer this one, you can actually, I will reopen the submission facility later on this week, maybe Thursday, and you can answer this again. Okay? Now, moving on to the presentation here. This one is quite exhaustive. It has a lot of points discussed. And again, some of these dis discussions are already part of Module 3 and not Module 2. So I guess we would only focus on, I want us to focus on only the types of boundaries. Now, let me reload that again because it seems that there is a problem loading it. So let me click on this. Okay. Okay, so I can present it now. So you have here, by the way, if you were confused, this is the button to click to navigate the whole um, presentation. So tectonic plates, that's just a review of what we learned about tectonic plates. Then now they interact in the boundaries, obviously, and you could have divergent boundaries, right? And here there are some details that I don't want to discuss because that would be part of Module 3, but basically you have here one plate moving that way, another plate moving this way, so they are diverging, right? And again, here's some more details which we will be discussing in Module 3, right? Now we go to convergent boundaries. So you have one plate going this way and the other plate going that way. They are colliding, right? So again, there are three types of that: the oceanic, continental, and again, there are some details that I would rather discuss in Module 3, right? But let's just move forward, and you can have the second type, which is oceanic versus oceanic. Spoiler alert, this is how the Philippines, or most of the Philippines, was created. But again, the processes about plate boundaries will be discussed in Module 3. So hold your uh, thought to that when we reach that module. Now, the last one is continental versus continental, and this is how India s- um, collides with the Eurasian plate, creating what we now call the Himalayas, the mountain ranges of Himalayas. Right, and then you have transform fold boundaries, which again the two pieces slide off each other by the edges, and this would create features like the strike strip slip fault, and these feature that we see in San Andreas fault. And if you're lucky, you can be at a place where the three of them are present. So you have A, B, and C. So you have divergent boundary near Juan de Fuca and this one. And then you have a transform boundary at this side, right? You see the layers misaligned because they are moving sideways. And then you can even have convergent side with Juan de Fuca with this plate here, right? Which I believe is the North American plate. Right, so here these are the explanations for why those things are happening. But again, I don't want to discuss too much because this would be now module 5. But let's just run through. So convection currents are one of them, one of the explanations. And then you can also have the equilibrium between the slabs of the lithosphere, and then you it goes all the way back to the mantles of the earth. I mean, the layers of the earth, both mechanical and compositional, which we have discussed at the first part of our discussions, right? Um, so these are descriptions of that, and again, you have those plates that we are familiar with already. And then for evidences, there are a lot of evidences for this, right? But again, the evidences will be discussed in module 5. Okay, so I think that would be all for our discussion of presentations, module 1 presentation, module 2 presentation 1, and module uh, 2 presentation 2. Okay, so if you are confused, let's go back to Mr. Help. This is presentation 1, the web page of module 2, and presentation 2 of module 2, the Prezi presentation. Again, do not worry. As of right now, these questions are not accessible. But on Thursday, I will reopen the submission facility. All you need to do is to check that box, and this should become available. And also, in fact, also I would also do that for even the previous ones, which are uh, presentation video presentation 4, the video, and presentation 5, the video of module 1, because again, some of the students had a difficulty realizing that they had to do was check that box to let it be accessible. Okay, so that would be all for today. Have a nice day, everyone. I hope that um, you keep on learning about stuff about science, and God bless.